Now that we know what the variance is, variance being the spread of the data, so how far away the data points are from the mean, how do we assign a single number to the variance? Just as with the measures of central tendency, we wanted a single number that we could look at to describe the data. Here again, we'd like a single number that we could use and say this is how spread out this data set is, and that's how spread out that data set is. How would we go about doing that? Well, what we're really trying to figure out is how far away each of these data points is from the mean. So let's take this example again. We have two students, one named Penny and one named Silver. And Penny's scores on 4 separate tests are 2, 4, 8, and 10. So we know Penny has a mean of 6. 2 plus 4 plus 8 plus 10 divided by 4 is 6. And Silver's scores are 4, 5, 7, 8. So Silver's scores are also, the mean of Silver's scores is also 6. You can see that 4 plus 5 plus 7 plus 8 over 4 is 6. So they have the same mean, Penny's just more spread out. How do we calculate how spread out each of them is? Well, one of the ways we could do it is by simply adding up all the differences between the mean and each of the data points, and then dividing that by the total number of data points. Let's try that for Penny. The difference between 6 and 8, that's 2. That's the first difference. The difference between 6 and 10, that's 4. Second difference, so far so good. Difference between 6 and 4, that's negative 2, because we're moving in the other direction. And the difference between 6 and 2, that's negative 4. Okay? And for Silver, the difference between 6 and 7, that's 1. The difference between 6 and 8, that's 2. The difference between 6 and 5, that's negative 1, because we're moving in the other direction. And the difference between 6 and 4, that's negative 2. Okay, so that looks good. Now let's add them all up. Well, we can see what the problem is straight away. If you add up 2 and negative 2, that's 0. And 4 and negative 4, that's 0. So we know the sum is 0 of all of these scores. Similarly, if you add up 1 and negative 1, and 2 and negative 2, that's also 0. So the full score there is 0. And if we divide these, we have 1, 2, 3, 4 observations here, and 1, 2, 3, 4 observations there, but 0 over 4 in both cases is just 0. So this didn't work. We don't get a score that tells us how spread out Penny is and how spread out Silver is. This is a problem. How can we fix that? Now this is being thrown away. How can we fix that so that we can actually get a score that tells us something meaningful? Well, the problem last time was that the scores kept cancelling each other out. So the 2 here cancelled out the negative 2 there, and the 1 there cancelled out the negative 1, the 4 cancelled out the negative 4. We would need some way of putting numbers together so that they didn't cancel each other out. We'd need some kind of function that made sure we always got positive numbers, never negative numbers. What kind of function could do that? Well, if we squared them, they would always be positive, and that might help. So let's try squaring all the numbers we get. So again, we take Penny, 6 to 8, that's 2. 6 to 10, that's 4. 6 to 4, negative 2. And 6 to 2, negative 4. Now instead of just taking the numbers, let's take the square of the numbers. 2 squared equals 4. 4 squared equals 16. Negative 2 squared also equals 4. And negative 4 squared also equals 16. Now let's do that again for Silver. Silver, that's 6 to 7, that's 1. 6 to 8, that's 8. That's 2. 6 to 5, negative 1. And 6 to 4, negative 2. Square all of these. 1 squared is 1. 2 squared is 4. Negative 1 squared is also 1, and negative 2 squared is also 4. Now, when you add up all these numbers, you get different results. So if we add up all the numbers for penny, we get 4, 16, 4, 16, that makes 40. If we add up all the numbers for silver, we get 1, 4, 1, 4, that's 10. And that means we get a different number when we divide them by the total number of observations. That's 40 over 4 equals 10. 10 over 4 equals 2.5. So we can say that penny has a variance of 10, while silver has a variance of 2.5. We have two different numbers for the variance. And that's very simple. It's exactly like calculating the mean, except that instead of calculating the actual value of the data points over the number of data points, you calculate the value of the differences squared over the number of differences. And you get one helpful answer. With larger data sets, of course, this becomes more complicated, and the formula is very, very slightly different. But this is essentially all there is to understanding or calculating variance.